Hello, everyone. Good morning. Let's turn on the cameras and let's get started here. Okay, we are going to begin here. So please turn on the cameras and get ready, everybody. Okay, so today I think it's going to be a little shorter class. I may or may not need the whole 1 hour time. We may be able to finish it little before 1 hour, maybe in about 45 minutes. Okay. Today we'll be working on absolute value equation. Last time we worked on the radical equations. Today we are working on absolute value equation. Okay. So in absolute value equation, as the name suggests, we'll have the equation involving some absolute values. Okay. And solving will be very easy in compared to the radical equation. So let's see how we can solve the absolute value equations. First, we are going to look at the definition of absolute value. When we say absolute value, an absolute value of a real number, x, okay, is defined as, look at the definition here, we write it as the absolute value of x equal to positive x if the value of x is greater than 0, or it will be negative x when the value of x is less than 0. So here is the example of graph of the absolute value function. So this entire graph that is here is the graph of the absolute value function. You can write it as this is the graph of y equal to absolute value of x. Okay, this is the graph of the function y equal to absolute value of x. And you can clearly see on this side, look at this screen. When the value of x is less than 0 or negative, here is the graph. And this graph is the graph of the function y equal to negative x. Okay, this is the graph of the function y equal to negative x. That's why in the definition here, I said when the value of x is less than 0, the absolute value is equal to negative x. Okay, and similarly, if the value of x is more than 0, on the other side, you can see more than 0 or positive, this is the graph of the absolute value function. That means this is y equal to positive x. So absolute value, in fact, contains two piecewise defined functions. For the value less than 0, it is negative x. And for the values greater than 0, it is positive x. For example, let me write here. If I need absolute value of 3, okay, if I need absolute value of 3, absolute value of 3, when I say 3 is a positive number, it's greater than 0. You can see if it is greater than 0, the value is exactly equal to this x. Whatever x is there, it is equal to that. So in this case, the absolute value will be equal to 3. Okay, but if you have a negative number, say for example, you want the absolute value of negative 5. So if we are calculating the absolute value of negative number, look here, when x is less than 0, it should be negative of that x. So it should be negative of that value, negative of negative 5. Okay, negative of negative 5. And negative of negative is positive. So that is equal to positive 5. So one quick note here that you have already explored in your classes is that the absolute value is always positive. You can see the absolute value of 3 is a positive 3. Absolute value of negative 5 is a positive 5. That is why, because the absolute value is always positive, you can see here, if you look at the graph of the absolute value function is always above the x-axis, because the y values above the y-axis, above the x-axis are always positive. Okay, the values are always positive. That's why this graph is above the x-axis. So that is the fundamental idea about the absolute value function. Now, one thing to know here, because we are exploring the equation, if you see any equation involving the absolute value, then that is called the absolute value equation. An equation involving absolute value is known as absolute value equation. So equation like this, let me write here just to show you the example. The example of the absolute value equation will be like, let's say, ax plus b or any other algebraic expression inside the absolute value is equal to some constant k, where a, b, and k in this case are real numbers. So here, a, b, and k are real numbers, So if you see equation like that, then those type of equations are called the absolute value equation. Ax plus b equal to k, that is the absolute value equation. So whenever you see absolute value equation, what you'll do is you'll try to transfer the equation to this format. Okay, the first thing that you have to do is you have to transfer the equation to this format. Okay, that is the general idea about the absolute value equation. But how do we solve the absolute value equation then? How to solve? How to solve the absolute value equation. So I'm going to give you a quick hint here. So if you have the equation like ax plus b equal to k, then what we know here, if we go to the definition here, if here is x inside, you can see that it can be positive x or it can be negative x, right? So if we use that concept, we are going to get two equations here. So from here, you'll write two equations. The first one will be positive ax plus b equal to k, and the other one will be negative ax plus b equal to k. So that means we can solve each of these equation to find the value of k, value of x. So here we solve that equation, we get one value of x. Similarly, on the other side, we solve this next equation, okay, and we find the value of x. So that is the basic idea. When you look at the example, this will make more sense. But you are just taking these fundamental notes here. While solving the absolute value equation, we have to write two equations. One with positive in front of the quantity inside the absolute value. The other one with negative in front of the quantity inside the absolute value. Okay, and when you solve each of them, you'll get two values of x or two values of unknown for the given equation. Also remember one thing, when you look at the graph of this absolute value function, this point here, okay, the sharp turning point that you'll see here, that point is called the vertex. This is called the vertex of the absolute value function, okay? And if the leading coefficient, when you factor this a out, if that a is positive, the graph will open up just like the quadratic function. And if we factor this a out and if it is negative, then in that case, the graph will open downward. Okay, two important things there. Okay, now let's look at a few examples. But before we move on to examples, are there any questions? Okay, there is a question in the chat. The question says, why 2 when we know that AV is always positive? The absolute value is always positive. So why we are writing two values here when the absolute value is always positive? As you can see here, when you look at these two little examples here, we get the absolute value positive. Absolute value is positive 5. Absolute value is positive 3. But if you look at the quantity inside the absolute value, when we have this positive 5, if you look at the quantity inside the absolute value, it is negative. Okay. And here, when we have a positive 3 again, but if we look at the value inside the absolute value, that is positive. So the quantity inside the absolute value can be positive or negative. That's why we have to take two values, okay? Just to take these two into consideration, because the actual value that lies inside the absolute value can be positive or negative. That's why we have to take both the equation. That is a good question. Thank you for asking. Okay, now we'll move on to example. If you don't have any other question, if you have question, you can put them on the chat and I'm going to answer them, okay? Or you can unmute yourself and ask me the question, whichever is good for you. Okay, here are the examples. So we are going to explore these three examples. We are not just solving the equation, we are also going to understand the fundamental idea behind each of these absolute values using the graphs, okay? So let's begin here with the first one. Here is the first one, A. So in A, we have absolute value of 3x minus 5 minus 4 is equal to 6. So as I told you before, first try to write this in standard form. Okay, try to write this in standard form. When I say standard form, you write it like this: ax plus b, the absolute value on one side, equal to k on the other side. Okay, move all constant to the other side. So in this case, you can see here is a negative 4. If you move this negative 4 to the other side, it will be positive 4. So you'll get absolute value of 3x minus 5 equal to, when you move this to the other side, it will be 6 plus 4, that is a 10. Okay. Now you can see we have the standard form, ax and b, okay, ax minus b equal to 10. So what we do is from here, we write two equations. So the first equation will be positive, and then 3x minus 5 equal to 10. And the other one will be negative in front of that, negative 3x minus 5 equal to 10. So we get two equations like this, okay? From the given absolute value equation, we get two different equations there. Now we need to solve each of these. The first one is, this is 10, by the way. Let me correct that. Okay, there we go. Now, the first one is positive, so that is 3x minus 5 equal to 10. Now, if you add 5 on both sides, it will be 3x equal to 10 plus 5 is 15. When you move 5 to the other side and add, that'll be 15. Now, if you divide on both sides by 3, you will get x equal to 15 over 3, that's a 5. So that is one value of x, okay? One value of x is 5. On the other side, now if we solve this one, there is a negative in front. So negative in front means it will change the sign. That will be negative 3x. And then negative and negative will be positive 5 equal to 10. And you get negative 3x. If you subtract 5 on both sides, 10 minus 5 will be 5. And next, what we do is we divide on both sides by negative 3. So if you divide on both sides by negative 3, you get x equal to negative 5 over 3. So we get two values of x. One is positive 5 and other one is negative 5 over 3. So we can finally write our answer, x equal to 5 and negative 5 over 3. So you can clearly see there are two values of x that will satisfy the given equation. Okay. Now what we are going to do is, after we solve this one, we are going to analyze all this work graphically. But before we move on to the graphical analysis, if you have a question on it, on how we solve it, you can ask me now. You can even send your question through chat. Okay, I don't see any questions. So we are going to look at the graph of this one. We are going to analyze this. So let's talk about the graph of this absolute value function. So analysis using graph. Okay. We are going to analyze this using graph. So in order to analyze the absolute value equation using graph, we take this equation here. Look at this equation here, the standard equation. We consider y equal to, you have absolute value of 3x minus 5. And on the other side, you have a 10. So what we do is we move this 10 on the left-hand side, so it will be minus 10. That's how we write the equation. Okay, this is the equation. Here we are writing the same equation as a function. So the function to represent this equation will be y equal to absolute value of 3x minus 5 minus 10. Now, one thing that we can do is this, y equal to, everybody look at the screen carefully now. Whatever factor is here in front, see, whatever is there with x, we'll try to factor that out. If we try to factor that out, it will be x minus, because when you factor it out, you are dividing. So when you divide 3x by 3, it will be x. Similarly, you have to divide this 5 by 3 because we are factoring that 3 from this group. So it will be 5 over 3. And then minus 10. So we get that equation. So here, this equation will tell you a lot of things. See, the first thing is this 3 is positive. Okay, this 3 is positive. Meaning of that is your graph will open up. Okay, graph will open up. That is the meaning of that 3. So you can write this 3 indicates that graph opens up. Okay, graph will open up. Next thing we know is by looking at these two values, this one here and this one here, we can tell the vertex. The vertex will be, when you write the vertex, listen here carefully. When you write the vertex, what you have to do is we have to change the sign of this quantity. Here is negative 5 over 3. So when you change the sign, it will be positive 5 over 3. And then we write this number as it is, negative 10 as it is. So out of these two numbers, see the first number that is here, the first number that is here will tell you whether the graph will open up or down. When you change the sign of this one, comma, you write this as it is, this will give you the vertex of the graph of the absolute value function. Okay. And if we use these three things and graph, let's see how the graph will look like. So in order to graph, first we need to draw the vertical and the horizontal axis like that. Your x and y axis. So what we do next is we look at the vertex. Vertex is 5 over 3. 5 over 3 is a little bit more than 1, which should be here. Okay, because 0 is here, so 1 should be there. And negative 10 means all the way down here. So there is the vertex. Vertex is somewhere down there. That is the vertex. Okay, the vertex is 5 over 3, comma, negative 10. That's your vertex. Now, the graph opens up. Because the graph will open up, the reason is this is positive. And you can see the graph of the absolute value function is like this, V-shaped graph. Okay, V-shaped graph. It's not like a parabola. Instead, it's a V-shaped graph. So we are going to sketch that graph now. So from here, we have to draw a V-shaped graph. Maybe on one side, it's going like this. On the other side, maybe it's going like that. So we can create a V-shaped graph like that. Okay, and then you can see, if you look at the screen carefully, you'll see that there are 2 points where the graph will cross the x-axis. See, there are 2 points where the graph will cross the x-axis. These 2 points are the answer to this absolute value equation. Okay. So what we see here is, since we have these 2 points, these are the answer to our equation. So clearly one value is positive, the other one is negative. That's what we got here. See, one value is positive. It's a positive 5. That means this point is 5, x is 5, and y is 0. So the x-intercept here is 5, 0. Similarly, on the other side, this value, which is quite close to origin, is negative 5 over 3. So this is negative 5 over 3. Negative 5 over 3, and y value must be 0. So this is how we can represent the absolute value using the graph, because when we draw the graph, you can clearly see how many answers you have. So here you can clearly see there are 2 answers. Okay, there are 2 answers. You can clearly see there are 2 answers, or 2 values of x that will satisfy the given equation. So always when you try to graph it, it's going to visualize whatever you are doing mathematically. If we just solve the math and get the answer may or may not make sense. But if you try to analyze and visualize that graphically, then you can clearly see the values. So that is your first example, example A. If you have a question, you can ask me now. Okay, look like there is no question. So we are going to move on to part B. So please copy the question, part B. Okay, I hope you are done copying it. Now let's begin solving process here. So in B, we have 3x plus 4 plus 9 equal to 0. Okay, so first we are going to write this in the standard form. We are going to write this in the standard form. When I say standard form, you can see here, we write it as, we write the absolute value on the left and we put the constant on the right. We did that in the first example also. Look here, we write the absolute value on the left and constant on the right. So we get absolute value of 3x minus 5 equal to 10. Okay. Similarly, when we do that here, we will get absolute value of 3x plus 4 is equal to, see, if we subtract 9 on both sides now, okay, if we subtract 9 on both sides, we'll get negative 9 on the right. Okay, we'll get negative 9 on the right. Now, let's see what you'll get from this one. Okay, Diksha, could you please unmute yourself and tell me, what do you see when you look at this absolute value equation?
What I see is that the 9 goes to the negative side. Like
it goes to the right-hand side and it becomes negative. Does that tell you anything? Do you see anything special about the equation by seeing that negative 9 on the right?
No.
No, you don't see it. That's okay. Let me check with Prakriti. What do you think? There is 9 on the right-hand side. Prakriti, please unmute yourself and tell me what is the implication of that negative 9 on the right-hand side. Unmute yourself, Prakriti.
I don't really know, but I think I have the same guess as Diksha.
Okay, got it. No worries, because you are learning it for the first time. So it doesn't mean that you should be able to tell the correct answer here. When you're trying, that is absolutely fine. 9? Could you please unmute yourself and tell me what you see there? Do you see anything special about that absolute value equation? Nine.
What do you mean by spatial?
So anything that you can see because there is a -9 on the other side? No?
Nah.
Okay. Okay. No worries. See, what we have studied here at the beginning is, so whatever is there inside the absolute value, look here, it can be a negative number, it can be a positive number, or it can be a negative number. Whatever is there inside the absolute value, your final result should be always positive, right? On the right-hand side, it should be always positive. For example, in the first part, absolute value of 3x minus 5 is a positive 10. We got a positive value, right? But here, we are getting a -9. That means this is not possible. Absolute value cannot be negative, right? So this is not possible. See, when we find the absolute value, you are getting a -9. Absolute value cannot be negative. Absolute value cannot be negative. That means, meaning of that is, this equation has no solution. Or when you graph it, you'll see that the equation will not, the function, when you graph the function, the graph will not cross the x-axis. So this equation has no solution. This implies the equation has no solution. So pretty much the answer to this question is, it has no solution. Okay, the equation has no solution. But we are going to verify this using graph so that it will be a little more clear. So when you draw the graph, as Vidya is saying in the chat, we'll start at a point, it will go up and it will never cross the x-axis. So we are going to look at that here. So let's make that analysis now. Let me write here. Analysis using graph. Because the graph should suggest the same thing. So if you look at our primary equation there, we have y equal to, this is the equation. We have y equal to absolute value of 3x plus 4. And then if you bring that 9 on the left-hand side, we write plus 9. This is our equation. Now, if you take these 3 out, always you have to factor the value that is attached with x out. So if you factor that out, 3 out, then you will get x plus 4 over 3 plus 9. 4 over 3, because when you factor this 3 out, you are dividing 3x by 3, that is x. If you divide 4 by 3, it will be 4 over 3. So now, when you look at these 3 here, that 3 suggests that the graph opens up. Okay, this 3 suggests that the graph opens up. And also, if you look at the vertex, to write the vertex, we have to change the sign of this number, change the sign of this number, so that will be -4 over 3. And then we have to write this number, that is a 9. -4 over 3, comma 9. -4 over 3 is like -1.33. Okay, now let's graph it. So what you have to do is you have to draw the vertical and the horizontal axis. So let's draw 2 axes to represent the graphing grid. Horizontal axis. Also draw the vertical axis like that. Okay, and you can label them as x and y axis. Now what we know is the vertex is at -4, 3, 9. -4, 3, here is 0. So negative will be on this side. Okay. negative 4, 3, somewhere there where I'm pointing with my mouse. And then positive 9, you go 9 unit up. So it will be somewhere there. So the vertex is somewhere here. Okay, vertex is somewhere here. And we know that the graph opens up. So from here, we have to draw a graph that is opening upward. So let's draw that. If we draw a graph opening upward, absolute value function is a V-shaped graph. So it will look like that. Okay, it will look like that. Now you can clearly see that this graph is not crossing the x-axis. Okay, this graph is not crossing the x-axis. This is negative 4, 3, 9. So graph is not crossing the x-axis. If it crosses the x-axis, then you'll have the solution. But this graph is not crossing the x-axis, so the equation has no solution. So always remember, your graph will tell you detail about the roots of the equation. X-intercept are the roots. Okay, if you have a question on this, you can ask me now. So we have one more to go. You can see in the first example, try to see what we are doing here. When you look at this standard equation, after we simplify, when you look at the standard equation, in the first example, we saw that the absolute value is equal to a positive number, a positive 10. When absolute value, okay, is equal to positive 10, we are getting two values there. In the second equation, we have the absolute value equal to negative 9. See, absolute value equal to negative 9. Absolute value cannot be negative. That means the equation has no solution. The graph is up there. It's not crossing the x-axis. That's what we have seen in our second example. Okay, now let's look at the third example. So third example, you can see the equation is already there in the standard form. In the third example, in C, the equation is already there in standard form. The absolute value of 10x, 10 minus 5x, okay, 10 minus 5x is equal to 0. It's already in the standard form. If it is already in the standard form, you can just write two equations from here. The first equation you can write is positive 10 minus 5x equal to 0. And the second equation that you can write is negative 10 minus 5x equal to 0. And let's see what we get after solving this. When we have positive, it is just that 10 minus 5x equal to 0. And if we move this 5x to the other side, you get 10 equal to 5x. Right? When you move this 5x to the other side, it becomes 10 equal to 5x. Now, you can divide on both sides by 5, so you get x equal to 2. When you divide on both sides by 5, you get x equal to 2. From the first equation, we obtain x equal to 2. Now, if you look at the second equation there is a negative sign. So if we distribute that negative, that will be negative 10. If we distribute that negative, negative and negative is positive 5x equal to 0. And if we add 10 on both sides, we get 5x equal to 10. Now you can divide on both sides by 5, so you get x equal to 2. So in both cases, you can see whether you take the first equation or second equation, you are getting x equal to 2. That means the only solution that we have is x equal to 2. We are not getting two values. We get one value. Meaning of that is the equation, okay, the equation will just cross the graph in one, cross the x-axis, or the graph of the function will cross the x-axis in just one point. That is the meaning of that. When you draw the graph of the function, okay, when you draw the graph of the function, you will see that the graph will cross the x-axis at only one point, x equal to 2. We are going to analyze that in a second. Before that, if you have a question, you can ask me. Again, Vidya has a question here. Why did we add -5 in the first one and then 10 in the second one? Because 5 is negative here, so I just want to move that 5 to the other side and solve it. But you can also subtract 10 on both sides and solve it. It's up to you how you want to solve it. In the first equation, if you want to subtract 10 and solve it, it will be -10 on the other side, and you'll divide by -5. You'll get the same result. So either way, it will work. Make sense, Vidya? Any other question? Okay, look like there is no question. So let's look at the graph to prove that there is just one answer, that is 2. Okay. So let's analyze. Analysis using graph. So here, our equation is 10 minus 5x equal to 0. So I can write y equal to absolute value of 10 minus 5x. But normally, if you look at all the examples that we have done so far, look at the screen now. See, here we have x in front. Also in the first one, we have x in front. So we'll try to write x in front in this one also. Okay, that is, we write like this. Y equal to, if I write x first, it will be -5x, then plus 10. 5x is negative, and then 10 is positive. So -5x plus 10. Then after that, what you'll do is y equal to, now here, if you try to factor this negative out, because there is a -5 in front, so you'll factor that -5 out inside the square root. So it will be x minus 2. The reason is, see, if I multiply by -5 times x, -5x, -5 times -2 is a positive 10. Okay, that's why you can factor it like this. Now, you know that the absolute value, see, these two things, -5 and x minus 2, there are two quantities inside the absolute value. The first thing, absolute value of -5 is a positive 5. So we can write that as positive 5. And then absolute value of x minus 2. So that is our standard form. So we have to do a little bit of work here to get that standard form first. Hold on, I lost my connection here. So just give me a second. Let's see if it is saved. Okay, it's not saved completely. So let me finish up that writing. So here I was getting x minus 2. Okay, now see, here is a 5. This 5, positive 5 in front, it suggests that the graph opens up. So make sure you add this in your note. So meaning of this 5 is graph opens up. Okay, next thing, if you think of the vertex here, let me show you how we have been writing the vertex. While writing the vertex, we used to write this number. Look at this screen. We used to write this number after x by changing the sign. It is positive 4/3. We write negative 4/3. And whatever number is there after the absolute value, look here, it is the absolute value closed here. And after that, whatever number is there, we used to write here. Now in this one, the number here is a -2. So when you change the sign, it will be +2. Okay, and then there is no number after this absolute value. Because there is no number after this absolute value, we can write it as 0. Okay, we can write it as 0. So the vertex is 2, 0. So whatever we are doing here, the goal is to prove that there is just one answer. Either way we solve, we just get one answer. That's what we are trying to prove here. Okay, we are trying to visualize that. So now let's graph this. So draw the axis now. I'm drawing it here, the horizontal axis, that is my x-axis. Now the vertical axis or y-axis like that. X, Y. Now if you look at the vertex, vertex is here at 2, 0. Here is x 0, and x equal to 2 will be somewhere there. So that is the vertex. That vertex is 2, 0. That vertex is 2, 0. Now, what we know is because this 5 is positive, the graph will open up. Okay, the graph will open up and we have to draw a V-shaped graph opening upward from there. So let's do that. So maybe the graph will look like that. Okay, the graph will look like that. That is the graph of the function y equal to absolute value of 10 minus 5x. Absolute value of 10 minus 5x. Or you can also write this as graph of this one. You can instead write 5 times absolute value of x minus 2. And you can clearly see in this graph will cross the x-axis at only one point, right? The graph will cross the x-axis at only one point. When it crosses the graph at only one point, then we can say that it has only one solution. Okay, it has only one solution. So this is the answer to the absolute value equation that we have seen. We verified this using the graph. So we have just one answer. If you have any question on that, you can ask me now. Otherwise, this is the last example for today.